June 5, 1967, 7:45 a.m., Sinai Peninsula. Egyptian Air Force Captain Hassan Kamal sprints across the tarmac toward his MiG-21. Sirens wail. Explosions blossom across the runway ahead of him, precise, methodical, devastating. He never reaches his aircraft. Within 3 hours, 400 Soviet-built fighters, the most advanced Moscow had ever exported, would be burning wreckage scattered across the desert. The attackers, French jet that every aviation expert in the world had written off as obsolete. The Mirage 3 had no radar worth mentioning. Its combat radius was a joke. At low speeds, it handled like a brick with wings. On paper, it shouldn't have survived the first engagement. Instead, it would humiliate a superpower. This is the story of how a failed design exposed a fatal flaw at the heart of Soviet air power, a flaw that Moscow refused to see until it was far too late. This is the story of how engineering compromises born of poverty turned into tactical advantages that wealth couldn't match. This is the story that changed everything we thought we knew about air combat. France, 1955. The country is broken. World War II didn't just damage France, it eviscerated the nation's aviation industry. Factories lay in ruins. The best engineers had fled or been captured. A decade of reconstruction had barely restored basic production capability, and the bleeding hadn't stopped. Colonial wars in Indochina had consumed men and material. The ongoing conflict in Algeria was hemorrhaging what little remained of the national treasury. France was attempting to maintain great power status with a budget that couldn't support it. Then came the intelligence reports from Moscow. The Soviets were deploying new strategic bombers, aircraft capable of reaching Paris within hours of launch, nuclear-armed, faster than anything France could currently field. The threat assessment was stark. Without a new interceptor capable of reaching Mach 2, French cities would be defenseless. The French Air Force issued its specification. It needed the interceptor fast. Development cycles measured in years, not decades. It needed it cheap. There was no money for expensive programs. And they needed it capable of catching bombers at altitudes and speeds that exceeded anything in the current inventory. They turned to Marcel Dassault. Marcel Dassault is one of aviation's most remarkable figures. Born Marcel Bloch, he had built aircraft for France before the war, been deported to Buchenwald for refusing to collaborate with the Nazi occupation, survived, changed his name, and rebuilt his company from nothing. He understood desperation. He understood making things work when the resources said they shouldn't. His response to the impossible, French requirement, would reshape air combat doctrine for generations. Dassault's engineering team, led by the brilliant Jean Cabareri, approached the problem with ruthless efficiency. Every component was evaluated against a single question. Does this help us reach Mach 2? If the answer was no, it was eliminated. No compromises, no safety margins. No concessions to versatility or secondary missions. Just pure, brutal velocity. The result looked more like a research vehicle than a fighter. A tailless delta wing swept back at an aggressive angle. A single engine, no redundancy. Fuel capacity that would give pilots maybe 20 minutes of combat before they were gliding home on fumes or ejecting over hostile territory. When the specifications reached NATO headquarters, American analysts laughed. British evaluators politely declined to purchase it. The Germans showed minimal interest. Even the French Air Force itself expressed reservations. The consensus was unanimous. The Mirage 3 was an evolutionary dead end. It's a desperate gamble by a nation that couldn't afford anything better. An aircraft that sacrificed too much in pursuit of specifications that were becoming less relevant as air combat doctrine evolved beyond pure interception. They were about to be proven catastrophically wrong. To understand why the Mirage 3 seemed doomed from birth, you need to understand the engineering trap Dassault had walked into. The delta wing configuration, that distinctive triangle shape, was considered suicidal for a production fighter in 1955. Experimental aircraft used delta wings. Research platforms explored their properties, but putting one on an operational combat aircraft, that was considered borderline irresponsible. Yes, the Delta offered certain advantages. Structural simplicity, the wing and fuselage could be integrated efficiently. Excellent performance at supersonic speeds, the shape naturally minimized wave drag. Good high-altitude capability, the large wing area provided lift in thin air. Clean profile that sliced through the air barrier. But the penalties were brutal. Without a horizontal stabilizer, The Mirage 3 had to land in a nose-high attitude. The pilot's forward visibility during approach was essentially zero. He was looking at sky, not runway. Landing speeds exceeded 170 knots, nearly twice what conventional fighters of the era required. The margin for error compressed to almost nothing. One mistake in speed management during approach, and the aircraft would either slam into the runway hard enough to collapse the landing gear or float endlessly down the runway, running out of concrete before running out of velocity. The engineering mathematics were unforgiving. Dassault's team calculated that a delta wing with 60 degrees of sweep would provide acceptable supersonic performance. Less sweep and wave drag would prevent the aircraft from reaching Mach 2. More sweep and low-speed handling would become completely unacceptable. The 60-degree compromise threaded the needle, but only barely. Here's where things got really ugly. When a delta wing aircraft pulls into a turn, it generates induced drag, the aerodynamic penalty for creating lift. All wings do this, but the delta's geometry makes the problem dramatically worse. The large wing area that provides lift at high altitude becomes a massive drag generator in maneuvering flight. Pull 5 Gs in a Mirage 3, and within seconds, you've lost a third of your airspeed. Keep pulling, and the losses compound. Energy bleeds away like water through a sieve. Within a minute of hard maneuvering, the aircraft that could exceed Mach 2 in level flight would be struggling to maintain 300 knots. Against a conventional fighter that could maintain energy while turning, the Mirage pilot faced an impossible dilemma. Turn hard and become progressively helpless as speed decays, or turn gently and give your enemy clean firing solutions. This wasn't a theoretical problem. It was the fundamental reality of delta wing aerodynamics. Every aviation engineer understood it. Every test pilot confirmed it. And then there was the fuel problem. The Mirage 3 carried approximately 4,000 liters of internal fuel. That sounds adequate until you understand what the Snecma ATAR turbojet did with it. The ATAR was a remarkable engine for its time. Reliable, relatively simple to maintain, and capable of the thrust needed for supersonic flight. What it wasn't in any sense was fuel efficient. At military power, the setting used for cruise and routine maneuvering, fuel consumption was acceptable. Switch to afterburner for combat, and the engine became a fuel incinerator. The reheat section that provided the extra thrust for Mach 2 flight consumed fuel at rates that would drain the tanks in minutes. Combat radius, barely 300 nautical miles without external tanks. Combat endurance at full power, perhaps 10 minutes. Practical combat maneuvering time, even less. External tanks could extend range, but they added drag and killed performance. You dropped them for combat and you'd better win fast because you weren't going to have fuel to try again. Israeli pilots who would later fly the Mirage developed a saying that captured this reality perfectly. You have 3 minutes to win. After that, you're flying home or you're not flying at all. Every engagement was a sprint. No prolonged maneuvering to achieve optimal position. No second passes if the first attack failed. No margin for error. Commit hard, kill fast, or die. On paper, this combination of limitations, poor low-speed handling, brutal energy loss in turns, minimal fuel capacity, high landing speeds, should have been catastrophic. The Mirage 3 violated almost every principle of sustainable air combat doctrine. In reality, these apparent flaws would become the key to everything. If you're finding value in this deep dive into Cold War aviation history, subscribe and hit that notification bell. What comes next changes everything we thought we knew about air combat. While Dassault's engineers built a desperate gamble in France, the McCoy-Gurevich Design Bureau in Moscow was constructing something very different. The MiG-21 entered service roughly concurrently with the Mirage 3, but it represented a fundamentally different philosophy of fighter design. Where the French embraced brutal minimalism, the Soviets pursued balance. Where Dassault accepted harsh trade-offs, Moscow demanded capability across every performance metric. The MiG-21 was conceived not as an individual weapon, but as a component within an integrated air defense system. It didn't need to do everything, it needed to do its specific role exceptionally well. The differences from the Mirage were apparent immediately. The MiG-21 used a tailed delta configuration, essentially a delta wing with an added horizontal stabilizer. This provided dramatically better low-speed handling. Pilots could see the runway during landing. Approach speeds were lower. The margin for error during the critical landing phase was substantially greater. The aircraft's RP-21 SAP-4 radar could actually track targets and guide missiles. Unlike the Mirage's primitive ranging system that just told you how far away something was, the MiGs radar provided genuine fire control solutions. It could guide the K-13 missile, the Soviet copy of the American Sidewinder, two targets that the pilot couldn't necessarily see. The design emphasized operational flexibility from the beginning. The MiG-21 was intended to operate from rough forward airstrips with minimal ground support. It could be serviced by relatively unskilled technicians using basic equipment. The aircraft would function in conditions where sophisticated Western jets would be hangar queens. Looking at the specifications, a MiG-21 should have dominated the Mirage 3. The Tumansky R-11 engine produced slightly less thrust than the Atar. But the MiG weighed nearly 1,000 kilograms less in combat configuration. This gave it a better thrust-to-weight ratio, the single most important metric for fighter performance. The radar could engage targets at ranges where the Mirage pilot was still squinting at the sky, trying to visually identify contacts. The integrated weapon system could launch missiles with reasonable probability of hitting while the French aircraft was still closing to gun range. Maintenance was a particular Soviet strength. MiG-21's engine could be pulled and replaced in the field within hours. A damaged aircraft could be back in service, while a comparable French jet was still waiting for specialized technicians. Major components were accessible through large panels. Troubleshooting procedures were straightforward. The Mirage demanded technicians with serious expertise. Its Atar engine was designed to be maintained and overhauled, not simply swapped out when problems arose. This worked fine for air forces with skilled personnel and established support networks. For expeditionary operations or nations with limited technical capability, it created persistent readiness problems. The weapons load comparison reinforced Soviet advantages. The MiG-21F carried two K-13 missiles plus a single-barrel 30mm cannon. The emphasis was on missile employment, get within firing parameters, launch, and disengage. The gun was backup, used only when missiles failed. The Mirage 3C carried two DFA 30mm cannons with more generous ammunition capacity. It could also carry Matra R-530 missiles, but early reliability issues meant pilots often preferred simpler alternatives. The aircraft was essentially designed for gunfighting with missile capability added as an afterthought. By every rational measure, thrust-to-weight ratio, radar capability, maintenance, accessibility, weapons integration, the MiG-21 should have dominated the Mirage 3 in any conceivable combat scenario. But there was something the specifications didn't capture, something buried deep in Soviet doctrine that would prove fatal. The MiG-21 wasn't designed to fight alone. This wasn't an oversight, it was a feature. Soviet air combat theory in the 1960s had evolved from World War II experiences and been modified by the advent of guided missiles. The resulting doctrine rested on a simple, logical premise. The future of air combat belonged to systems, not individual heroes. The theory worked like this. Ground-based radar networks would provide initial detection of incoming threats. Multiple stations would triangulate contact positions, allowing controllers to track targets with precision unavailable to individual aircraft. Fighter aircraft would be scrambled based on controller direction. They would be vectored toward intercept positions that maximize their probability of success. The pilots didn't need comprehensive situational awareness. The ground controllers had that. The pilots just needed to fly where they were told. The fighter's onboard radar would handle the final intercept phase, require the target being tracked by ground control. Lock up the weapon system. Fire missiles at beyond visual range distances where the enemy couldn't even see you coming. The entire engagement could be completed without the Soviet pilot ever seeing his target visually. Scientific, systematic, modern. Dogfighting was obsolete. A relic of propeller-driven warfare when pilots had no choice but to maneuver for position and shoot with limited-range weapons. The new era demanded different skills: system trust, procedural discipline, integration with the larger defensive network, maneuverability, secondary consideration. The engagement would be resolved before it became relevant. Speed and climb rate, critical to reach intercept position quickly. Pilot initiative, unnecessary. The ground controllers managed tactics. The MiG-21 was optimized for exactly this paradigm. Its radar worked best when slaved to ground-controlled data, which provided initial target designation. Its weapons load emphasized missiles over guns. Its fuel and aerodynamics were balanced for high-altitude supersonic intercepts, the profile that Soviet doctrine envisioned. This philosophy had a name, Ground Controlled Intercept, and it worked beautifully. In theory, the problem was that theory and combat occupied different realities. Missiles in the 1960s were temperamental technology at best. The K-13, despite being copied from proven American design, had an effective engagement envelope roughly the size of a football field. Fire outside that envelope, wrong angle, wrong closure rate, wrong altitude differential, and you'd wasted your shot. The missile would either fail to track or run out of energy before reaching its target. Radar systems of the era failed with depressing regularity. Environmental factors, electronic interference, maintenance issues, operator error, any of a dozen problems could reduce the sophisticated fire control system to expensive dead weight. Ground control, for all its theoretical benefits, could be jammed. Communications could be disrupted. Controllers could be overwhelmed when multiple engagements develop simultaneously. The beautiful tactical picture could dissolve into chaos in seconds. And when any of these elements broke down, the Soviet pilot found himself in desperate trouble. He was flying an aircraft optimized for fights that weren't happening. His radar might be useless. His missiles might be expended or non-functional. Ground control might be screaming contradictory instructions or simply absent. Now he was alone, in a visual-ranged knife fight, flying an aircraft with limited fuel and handling characteristics that, while acceptable, didn't reward the kind of aggressive maneuvering that close combat demanded. The doctrine hadn't prepared him for this. The training hadn't emphasized this. The aircraft systems weren't designed for this. The French and Israeli pilots flying Mirages had no such illusions. They operated with minimal supporting infrastructure. French doctrine emphasized aircraft autonomy and pilot initiative because France couldn't afford Soviet-style ground control networks. The pilots made decisions themselves. They trusted their own judgment because they had no choice. Israeli operators took these principles even further. Their tactical culture assumed things would go wrong. It assumed communications would fail. It assumed missiles would malfunction. It trained pilots to win anyway, through aggression, initiative, and the ability to exploit whatever advantages they could find in the chaos of actual combat. Neither aircraft's designers fully understood it yet, but they had created a philosophical collision course. June 1967 would provide the verdict. June 5, 1967, 7:10 a.m. The first wave of Israeli Mirage 3 South crosses the Mediterranean coast at 50 feet above the waves. They're flying profiles that would terrify peacetime safety officers. Full afterburner. Terrain masking, radio silence absolute. 200 aircraft are in the air. The largest coordinated strike the Israeli Air Force has ever attempted. Their targets every major Egyptian airfield in the Sinai and along the Nile Delta. Israeli intelligence has spent months studying Egyptian operations. They know when the morning patrols return. They know when the pilots eat breakfast. They know the alert procedures and response times. Most importantly, they know that Egyptian radar coverage has a gap at low altitude over the sea. The Mirages thread through that gap at speeds that turn the aircraft into vibrating, barely controllable projectiles. Pilots can feel every wave below them through the flight controls. One mistake, one moment of inattention, and they'll be cartwheeling across the Mediterranean. They don't make mistakes. What happens next defies everything Soviet defensive doctrine was designed to prevent. The Mirages arrive at their targets precisely as Egyptian pilots are eating breakfast, a vulnerability Israeli planners had identified and exploited ruthlessly. The Soviet-designed dispersal procedures, revetments, and alert postures that were supposed to protect these aircraft prove worthless against attackers moving at 600 knots with precise intelligence. But the Israelis aren't bombing randomly. They understand Soviet runway repair procedures intimately. Years of intelligence gathering have revealed exactly how Egyptian engineer units respond to bomb damage. The standard procedure: fill craters with rubble and compacted earth, starting with the main runway, working outward. Israeli weapons are aimed to create damage patterns that exploit these procedures. Runway intersections go first, the hardest points to repair quickly. Taxiways next, trapping aircraft in their revetments, even if the main runway is patched. Maintenance facilities and fuel storage hit simultaneously, destroying the infrastructure needed to restore operations even after runways are cleared. Every bomb is placed to maximize repair time. Every target selected to cascade problems through the Egyptian response system. Aircraft parked in revetments, protective berms designed to shield them from nearby explosions, are systematically destroyed. The revetments that were supposed to save them become tombs, channeling blast effects directly into the aircraft they were meant to protect. By 10 a.m., the Egyptian Air Force effectively ceases to exist. The numbers are staggering. 400 aircraft destroyed, 300 on the ground caught in the initial strikes, another 100 shot down trying to respond. Egyptian losses include virtually every operational MiG-21, MiG-19, and MiG-17 in the inventory. 100 pilots dead. Many more captured or injured. Total Israeli losses, 19 aircraft. The airfield strikes demonstrated something profound about the gap between Soviet defensive theory and operational reality. But the air bases were just the beginning. What happened when Arab fighters actually managed to reach the sky would prove even more devastating to Soviet assumptions. June 6, 1967. Early afternoon. Captain Giora Ram leads a formation of 4 Mirage. 3 south home from a ground attack mission near the Suez Canal. They've been hitting Egyptian armor columns for 2 hours. Their aircraft carry battle damage from anti-aircraft fire. External stores are empty. Fuel gauges are approaching minimums. Ram is already calculating the fuel required to reach home base when his wingman calls contact to Egyptian MiG-21s. Hi, coming fast. Perfect intercept geometry. The MiGs have been vectored by ground control that survived the morning strikes. They have altitude advantage, the cardinal position in air combat. They have energy advantage, fresh from takeoff while the Israelis are fuel depleted. They have weapons, full missile loads against Mirages that have already expended their ordnance. According to every Soviet manual ever written, the engagement should last 30 seconds. Israelis should be dead before they can react. The Egyptian formation leader, a captain trained by Soviet advisors to Soviet standards, executes textbook doctrine. Maintain formation integrity. Your wingman is your strength. Close to optimal missile range, don't waste shots at excessive distance. Fire and withdraw. There's no need to enter a maneuvering fight when missiles can do the work. Ram does something the doctrine doesn't anticipate. He accelerates. Instead of turning to evade, which would bleed the Mirage's energy exactly as the Delta Wing's critics predicted. Ram pulls into a climbing turn, not a defensive break, not an attempt to flee, an attack. The physics seem impossible. Israelis are lower, slower, and depleted. The textbooks say they should be trying to extend, to reach friendly airspace, to survive. But Ram understands something about the Mirage that the textbooks don't capture. In the vertical plane, the Delta Wing's liabilities become assets. The same large wing area that creates drag in horizontal turns provides lift in a zoom climb. The aircraft can convert horizontal energy to altitude efficiently, trading speed for position. And the Egyptians, trained to maintain formation integrity, try to follow together. That coordination, drilled into them through countless hours of Soviet-supervised training, costs them everything. Maintaining 2-ship formation while pursuing climbing targets requires both aircraft to match maneuvers. The wingman can't simply follow his element lead. He has to maintain spacing, which slows his turn rate. The formation as a unit climbs slower than either aircraft could individually. The Mirages continue accelerating into the vertical, converting their remaining energy into altitude, while the MiGs hemorrhage their initial advantage, trying to stay together. Within 30 seconds, the geometry has completely reversed. The Mirages reach the top of their zoom climb with energy remaining. They're above the MiGs now. Egyptians, having depleted their speed chasing, are low and slow, the worst possible state for any fighter. This is the moment when pilot initiative determines everything. The Egyptian wingman, finding himself in a situation no simulator had prepared him for, does exactly what his training emphasized. He attempts to reform on his element leader, re-establish the tactical formation. Contact ground control for updated instructions. It's those few seconds of procedural compliance cost him his life. Ram reverses at the apex of his climb, pulls lead on the confused wingman, and triggers his cannon. The DFA 30mm rounds, the weapons that Soviet doctrine considered obsolete backup, tear through the MiGs fuselage. The element lead, trying to cover his wingman, pulls hard into Rom's second aircraft. Another burst of cannon fire, another MiG trailing smoke and flame toward the desert floor. Total elapsed time from initial contact, approximately 90 seconds. Both Egyptian aircraft destroyed. All 4 Israeli Mirages recovered to base, low on fuel but intact. This pattern, Soviet-trained pilots executing doctrine correctly but dying anyway, would repeat itself throughout the Six-Day War and throughout the war that followed 6 years later. The initial Soviet response to the Six-Day War results was predictable. Arab incompetence, poor maintenance, inadequate training, the usual excuses deployed whenever client-state forces using Soviet equipment suffer embarrassing defeats. There was truth in these explanations. Egyptian maintenance standards weren't comparable to Soviet norms. Training hours were limited by budget constraints and aircraft availability. Pilot selection processes were sometimes influenced by political factors rather than pure aptitude. But these explanations missed the deeper failure. They provided comfortable narratives that avoided uncomfortable questions. The problem wasn't that Egyptian pilots were poorly trained. The problem was that they were perfectly trained for a war that didn't happen. Soviet doctrine assumed ground control would provide situational awareness. When Israeli jamming disrupted communications, Egyptian pilots had no framework for independent decision-making. They'd never been taught to fight without the voice in their headset telling them what to do. Soviet doctrine assumed missiles would resolve engagements at range. When missiles failed to track, as they frequently did, against maneuvering targets at non-optimal parameters, pilots were suddenly in gunfights they'd never seriously practiced. The cannon was backup. Nobody had explained what to do when backup became primary. Soviet doctrine assumed formation discipline was paramount. The wingman protects the leader directs the engagement, maintain integrity at all costs. When Israeli pilots broke all formation rules to exploit transient advantages, Arab pilots couldn't adapt. Their training hadn't prepared them for enemies who fought like individuals rather than elements. The specific engagement sequences from the Six-Day War reveal these failures repeatedly. Egyptian pilots did everything correctly. They maintained formations. They followed procedures, executed the tactics they'd been taught, and they died. It's not because they were bad pilots. No, not because their aircraft were inferior. Because the entire conceptual framework underlying their preparation didn't match the reality of combat against an adversary who refused to cooperate with Soviet assumptions. The Mirage 3 succeeded not because it was a better aircraft by most objective metrics. It wasn't. But because it was flown by pilots whose entire training and culture emphasized exactly what the MiGs' training and culture neglected: individual initiative. Israeli pilots were expected to assess situations themselves and make decisions without waiting for instructions. They didn't need ground control to tell them what to do because they'd been trained to figure it out. Adaptive decision-making. When the plan failed, as plans always do, Israeli pilots improvised. They'd practiced fighting from disadvantaged positions. They'd learned to exploit small opportunities. They understood that combat rewards aggression and punishes hesitation. The ability to win when everything goes wrong? The Mirage's limitations had forced this mindset. Couldn't rely on sophisticated systems because you didn't have them. Couldn't count on extended engagements because you didn't have the fuel. You had to win fast and win decisively, using whatever advantages you could create through skill and aggression. The MiG-21 was a fine aircraft operated exactly as designed. The problem was that combat never cooperated with design assumptions. October 6, 1973, Yom Kippur, the Day of Atonement. 6 years after the Six-Day War's humiliations, Arab air forces return with a vengeance. Egyptian and Syrian forces launch coordinated attacks while Israel observes its holiest religious holiday. This time, everything is different. Soviet advisors have spent 6 years analyzing every engagement from 1967. Doctrine has been refined. Training programs have been overhauled. The equipment pipeline has delivered substantially upgraded aircraft. The MiG-1MF variant, now in Egyptian and Syrian service, is a different animal from the aircraft that died over Sinai in 1967. Better radar with improved acquisition ranges. More sophisticated avionics with greater reliability. Enhanced weapons integration that allows more effective missile employment, upgraded engines with better thrust characteristics. Arab pilots have accumulated more flight hours. They've practiced the specific scenarios where 1967's failures occurred. Soviet advisors have worked to instill individual initiative while maintaining doctrinal discipline. This time, Moscow's planners believe the outcome will be different. It isn't. Israeli Mirage 3 South, now nearly 2 decades old in design. The same basic aircraft that scored in 1967 continue achieving favorable exchange ratios against purpose-built Soviet fighters that should decisively outclass them. The improvement in Arab capabilities is real. Engagements are harder. Israeli losses are higher than in 1967. The war will ultimately cost the IAF dearly in pilots and aircraft. But the fundamental pattern remains unchanged. Analyzing combat reports from the Yom Kippur War, the same dynamics emerge repeatedly. Mirage pilots achieve positional advantage before committing to engagements. They don't chase, they don't rush. They maneuver for favorable geometry and only commit when the setup is right. They use vertical maneuvers to manage energy states, exploiting the Delta Wing's zoom climb capability that seems counterintuitive but proves devastatingly effective. Up, over, down with energy advantage. They break off engagements that develop unfavorably. No ego investment in continuing a fight that's turning against them. Reset the tactical situation. Use speed advantage to disengage, reposition, and re-engage on better terms. Soviet-trained Arab pilots continue showing the same patterns that failed in 1967. They maintain formation integrity when breaking formation would serve them better. The training is too deep, the doctrine too ingrained. Even pilots who intellectually understand the problem can't overcome conditioned responses under the stress of combat. They execute pre-planned tactics when adaptation is required. Playbook says do this when that happens. But the Israelis keep creating situations the playbook doesn't cover. They rely on ground control for awareness when ground control is degraded or absent. The system of systems approach that Soviet doctrine emphasized requires every component to function. When components fail, the whole degrades. When everything works perfectly, MiG formations remain formidable. On the good days, Arab pilots achieve kills and survive engagements. But combat doesn't provide many good days. When systems break down under stress, and they always break down under stress, individual pilots find themselves fatally unprepared for what comes next. Moscow's response to 2 successive wars worth of unfavorable results reveals the depth of their dilemma. The easy answer would have been to fundamentally reconsider Soviet approaches to fighter design and pilot training, acknowledge that the ground-controlled intercept paradigm contained fatal assumptions, except that pilot initiative mattered more than system integration. Redesign both aircraft and doctrine around these new realities. This is not what happened. Instead, Soviet engineers attempted to address specific Mirage advantages through technological improvement. If the problem was that existing aircraft couldn't match Western performance across the flight envelope, build new aircraft that could. The MiG-23 introduced in the early 1970s represented this philosophy. Variable geometry wings that could sweep forward for low-speed handling and sweep back for supersonic performance. The best of both worlds, at least in theory. More powerful radar with greater range and improved tracking capability. The weapons system could now engage at distances that even the Mirage's speed couldn't easily evade. Greater payload capacity, allowing more missiles and more ordnance options. The aircraft could carry weapons for multiple engagement scenarios rather than being optimized for a single mission type. Improved avionics providing better situational awareness without requiring constant ground control input. The pilot had more information available in the cockpit. On paper, the MiG-23 should have decisively outclassed the Mirage 3. In practice, Syrian MiG-23 units faced Israeli Mirages during operations in the early 1980s. The exchange ratios remained favorable to aircraft designed in the mid-1950s. The MiG-23 had inherited every systemic problem that limited the MiG-21. The variable geometry wing system was mechanically complex. Added weight, it created additional maintenance requirements. It introduced failure modes that didn't exist in simpler designs. When the wing sweep mechanism malfunctioned, and it did regularly, under field conditions, the aircraft became almost unflyable. The improved avionics required more electrical power and proved prone to failures in the heat and dust of Middle Eastern operations. Systems that worked beautifully in Russian test facilities struggled in combat environments. The more powerful radar and weapon system demanded more sophisticated maintenance than many client state forces could provide. Theoretical capability that couldn't be maintained in practice wasn't capability at all. Most importantly, Soviet doctrines still emphasized centralized control and procedural execution. Better aircraft couldn't compensate for pilots who weren't trained to use their improved capabilities creatively. Technology couldn't fix a philosophy problem. Eventually, Soviet designers would acknowledge what the Mirage encounters had demonstrated. The MiG-29 and Su-27, developed in the late 1970s and entering service in the 1980s, represented a fundamental departure from earlier Soviet fighter philosophy. These aircraft were genuine dogfighters, built around maneuverability rather than just speed and systems. Featuring thrust vectoring, advanced aerodynamics, and performance envelopes designed for close-range combat. They incorporated lessons that could only have come from analyzing why earlier Soviet designs failed against Western opponents. Better close-range weapons, more robust construction, helmet-mounted sights for off-boresight missile engagement, systems that enhanced rather than replaced pilot initiative. The new Soviet fighters were formidable. They could compete with contemporary Western aircraft on relatively equal terms. But they came at enormous cost. Far more expensive to develop than their predecessors. Far more demanding of training and support infrastructure. The manufacturing complexity that enabled their capabilities also limited production quantities. The economic burden of matching Western air power fell on a Soviet economy already straining under military expenditure. Resources that might have gone to consumer goods, industrial modernization, or economic reform were instead consumed by fighter programs designed to counter French jets from the 1950s. A French design born of desperation and budgetary constraint had forced a superpower into an arms race it ultimately couldn't afford. There's a seductive comfort in numbers. Maximum speed, precisely measurable. Service ceiling, exactly quantifiable. Radar range, empirically testable. Weapons load, simple to compare. Soviet military culture excelled at optimizing these metrics. Each new aircraft variant could demonstrate improvement over its predecessor through objective measurements. Progress was documentable. Results could be presented to Central Committee officials who needed charts and graphs to justify expenditures. The problem, starkly revealed by combat results, was that none of these numbers correlated reliably with actual combat effectiveness. The MiG-21 had better specifications than the Mirage 3 in most measurable categories. It lost anyway. The MiG-23 improved on MiG-21 specifications across the board. It still couldn't reliably defeat Mirages. Something was missing from the analysis. Something that couldn't be reduced to numbers on a specification sheet. What does correlate with combat effectiveness? Pilot initiative? The willingness and ability to make independent decisions under pressure? Unmeasurable? You can't test for it, can't specify it, can only train for it. And even then, you never know if you've succeeded until combat provides the examination. Tactical flexibility, the capacity to adapt when plans fail, unquantifiable. How do you measure adaptability? Simulators can't replicate the psychological stress of actual combat. Exercises can't generate the genuine chaos of hostile engagement. The ability to exploit transient opportunities, recognizing and acting on momentary advantages before they disappear. It's impossible to specify. The window might last 2 seconds. Either you're prepared to use it or you're not. Israeli Air Force culture emphasized exactly these qualities from the first day of flight training. Student pilots were expected to critique their instructors, to question established procedures, to develop individual tactical approaches. This created friction and required confident leadership, but it produced pilots who thought for themselves. Innovation was rewarded rather than punished. A pilot who tried something unconventional and succeeded was celebrated. One who failed was debriefed constructively, not condemned. The culture tolerated experimentation because experimentation was how improvement happened. Deviation from standard procedures was acceptable, expected, even when circumstances warranted. The manual was a starting point, not a prison. Pilots were trusted to recognize when the manual's assumptions didn't match reality. Soviet training produced the opposite. Procedural discipline was paramount. The system worked. Individual pilots didn't need to improvise because the system handled tactical decisions. Trust the system. Formation integrity must be maintained. The wingman protects the leader executes the plan. Deviation is failure. Ground control provides awareness. The pilot's job is to fly the aircraft and execute instructions. The big picture is someone else's responsibility. These qualities served peacetime operations well. Soviet pilots could execute complex coordinated operations with precision. They could perform admirably in exercises where the scenario unfolded as planned. In the chaos of actual combat against adversaries who refused to cooperate with Soviet assumptions, these same qualities became lethal handicaps. The Mirage 3 thrived in Israeli hands because its characteristics rewarded exactly what Israeli training produced. The aircraft couldn't rely on sophisticated systems. Israeli pilots had learned not to rely on sophisticated systems because they didn't have them. The aircraft's fuel limitations demanded aggressive, decisive engagement. Israeli pilots were trained for aggressive, decisive engagement. The Delta Wing's handling rewarded vertical tactics and energy management. Israeli pilots had developed vertical tactics because that's where the Mirage's geometry worked. The aircraft's limitations had inadvertently selected for exactly the pilot qualities that mattered most in actual combat. After analyzing decades of Cold War aviation data, I've come to believe the Mirage MiG competition reveals something fundamental about military effectiveness, something that extends far beyond fighter aircraft. Winning isn't about superior platforms, it's about alignment. The Mirage 3 succeeded because French and Israeli operators, whether by design or accident, created an ecosystem where every element reinforced every other element. The craft characteristics rewarded aggressive vertical tactics and energy management, the Delta Wing's zoom climb capability, the aircraft's excellent thrust-to-weight ratio, its simple but reliable systems, all of these supported the tactics that pilots developed. Doctrine emphasized pilot autonomy and decentralized decision-making. This matched the aircraft's minimal dependence on ground infrastructure. The Mirage didn't need ground control to function effectively, and the Doctrine didn't assume ground control would be available. Training produced pilots who could improvise under pressure. This was necessary because the aircraft's limitations, short combat endurance, poor low-speed handling, challenging landing characteristics, demanded excellence. Mediocre pilots couldn't succeed in the Mirage. The training system didn't produce mediocre pilots. Logistics were designed for field repair and rapid turnaround. The maintenance approach assumed skilled technicians but accepted improvisation when necessary. Parts cannibalization was tolerated. Creative solutions were encouraged. This enabled sortie rates that Soviet procedures couldn't match. Every element supported every other element. Remove any one, and the system would have degraded. Together, they created capability that exceeded what any individual component could provide. Soviet aviation had misalignment at every level. Aircraft designed for integrated air defense relied on ground control networks that combat inevitably disrupted. When the network failed, the aircraft's design assumptions became liabilities. Doctrine emphasized procedures that couldn't adapt to fluid situations. The playbook assumed cooperative enemies. Real enemies didn't cooperate. Training produced competent operators who executed instructions well. Didn't produce innovative fighters who could win when the instructions stopped coming. Logistics optimized for peacetime efficiency became brittle under wartime stress. The maintenance procedures that kept readiness high in garrison conditions couldn't sustain operations when supply chains degraded. Any single element failing cascaded into comprehensive system degradation, and in combat, elements always fail. The MiG-21 was an excellent aircraft when everything worked as designed. The Mirage 3 was a compromised aircraft that worked anyway. That difference proved decisive. Here's the brutal irony that Moscow never quite grasped. MiG-21 was cheaper to build than a Mirage 3. Soviet production efficiency could generate fighters in quantities that Western nations couldn't match. On a pure cost-per aircraft basis, Soviet aviation was economically superior. But the MiG required an entire supporting ecosystem to achieve its design performance. Ground control networks spanning hundreds of square miles. Early warning radar installations, communications infrastructure linking scattered facilities, hardened command bunkers with trained controllers, logistics networks capable of supplying all these installations. The complete Soviet air defense system represented enormous investment. Building the fighters was almost incidental. The real cost lay in everything those fighters needed to function effectively. When the system operated properly, Soviet air defense was formidable. The integrated approach could indeed defeat attacks, detect threats early, vector interceptors efficiently. The theory wasn't crazy, but complexity created brittleness. Disrupt communications, and controllers lose track of the tactical picture. Jam radar, and early warning evaporates. Kill a single node in the command structure, and the system degrades across a wide area. The components were individually survivable. The system as a whole was fragile. The Mirage, born of French poverty and Israeli necessity, needed almost nothing. An Israeli Mirage unit could operate effectively from a damaged runway with basic tools. The aircraft didn't care if ground control networks were functioning. It wasn't designed to need them. Pilots made decisions without waiting for controller input because they'd never expected controllers to be available. Creative ground crews kept aircraft flying through improvisation that would have horrified Soviet maintenance doctrine. Parts cannibalization was standard procedure when supply chains broke down. Maintenance schedules were treated as guidelines rather than requirements. This resilience proved more valuable than peak capability under actual combat conditions. The French built a fighter for the war they expected to lose. The Soviets built a fighter for the war they expected to win. The French assumptions about fighting outnumbered, without adequate infrastructure, with limited resources, matched what actually happened in combat. Soviet assumptions about coordinated operations, functioning systems, and procedural execution broke down immediately. Guess which philosophies survived contact with reality? The Mirage 3's success against Soviet-designed fighters had implications that extended far beyond the Middle East theater where the engagements occurred. NATO planners in the 1970s faced a terrifying numerical disadvantage across the board. Warsaw Pact ground forces outnumbered NATO forces substantially. Soviet tactical aircraft could swamp NATO defenses through sheer quantity. The math seemed impossible to overcome through conventional means. But repeated Mirage victories in the Middle East suggested something the raw numbers missed. Soviet air power doctrine contained fundamental vulnerabilities. The integrated approach that seemed so threatening assumed conditions that determined adversaries could disrupt. The numerical advantage relied on systems that degraded under stress. Qualitative superiority in training, doctrine, and equipment might offset quantity disparities. Not completely. Nobody believed one Western fighter could defeat 3 Soviet aircraft. But enough to matter. Enough to make conventional defense viable rather than simply relying on nuclear deterrence. This confidence, whether fully justified or not, shaped Western force structure decisions for a generation. Fewer aircraft, but better trained pilots. Quality over quantity. Less emphasis on mass production, more on individual capability. Every aircraft and every pilot had to count because there wouldn't be many of either. Acceptance that the West couldn't match Soviet numbers combined with belief that it didn't need to. The right aircraft with the right pilots using the right tactics could prevail. American fighter programs of the 1970s reflected these conclusions. The F-15 was designed around air-to-air superiority with secondary ground attack capability. A pure fighter rather than a multi-role compromise. The F-16 prioritized maneuverability and pilot interface over complex systems. Both programs incorporated lessons that combat in the Middle East had validated. The importance of thrust-to-weight ratio, the value of pilot visibility and aircraft handling. The need for reliability over sophistication. For the Soviet Union, the strategic implications were worse. Client nations began questioning the value of Soviet equipment. Egypt, where Soviet advisors had invested years of effort, would eventually switch allegiance entirely, purchasing American F-16s to replace MiGs that had repeatedly proven inadequate. Export markets that once seemed captive now considered Western alternatives. Nations that needed effective military equipment, not just political alignment, looked at combat records when making procurement decisions. The credibility of Soviet power projections suffered in ways no specification sheet or propaganda effort could repair. When your equipment fails publicly and repeatedly against supposedly inferior opponents, no amount of advertising overcomes the demonstrated results. From my analysis of Cold War aviation data and its long-term consequences, I see echoes of the Mirage and MiG competition in virtually every contemporary military aviation program. The tension between system complexity and operational resilience remains unresolved. Every new fighter generation adds capabilities that require additional support, maintenance, and infrastructure. The integration becomes more sophisticated. Potential failure modes multiply. Centralized versus decentralized command structures still divide military thinkers. Network-centric warfare promises coordination advantages that would make Soviet ground control look primitive. But networks can be jammed, spoofed, or destroyed. What happens then? The challenge of aligning technology, doctrine, training, and culture persists across every air force on Earth. New aircraft enter service and immediately reveal mismatches with existing procedures. Training programs struggle to adapt. Doctrine lags behind capability. Specific aircraft have changed. The fundamental questions haven't. Will your pilots be able to adapt when the plan fails and the network goes dark? Will your systems function when infrastructure degrades and logistics break down? Will your doctrine survive contact with an enemy who refuses to cooperate with your assumptions? The MiG-21 pilots over Sinai in 1967 and 1973 could have answered those questions if anyone in Moscow had thought to ask them. Marcel Dassault didn't set out to revolutionize air combat or humble a superpower. He was trying to meet an impossible requirement with inadequate resources. A broken nation needed a fighter it couldn't afford. Built by an industry that had barely recovered from destruction, against a deadline that allowed no margin for error. The compromises his engineers accepted were born of desperation, not strategy. The Delta Wing's limitations were obvious to everyone who studied it. The fuel capacity problems were inherent in the design. The landing characteristics would challenge pilots throughout the aircraft's service life. Every aviation expert who evaluated the Mirage 3 in the early 1960s identified these issues. The consensus judgment, evolutionary dead end, specialized interceptor, sacrificed too much flexibility seemed reasonable based on the evidence available. And yet, the constraints that seemed to doom the Mirage forced operators to develop something no specification could capture. The fuel limitations meant pilots had to win fast. This produced aggressive, decisive fighters who didn't waste time maneuvering for perfect position. The Delta Wing's handling characteristics demanded mastery of energy management. Pilots who couldn't handle the aircraft washed out. Those who remained became experts in vertical tactics and zoom climbs. The simple systems meant pilots couldn't rely on technology to save them. They had to rely on skill, judgment, and initiative. The training system adapted to produce pilots with those qualities. The aircraft's demands created exactly the kind of warriors that Soviet doctrine's rigidity couldn't produce. The Soviets built what they wanted. Dassault built what he could afford. Reality preferred the latter. The MiG-21 deserves recognition as an excellent aircraft. It met every specification Soviet designers established. It functioned precisely as intended within the integrated air defense system for which it was designed. Production numbers exceeded any Western fighter by enormous margins. The aircraft served in more air forces than any other supersonic fighter in history. Judged by the criteria its designers established, the MiG-21 was a triumphant success. It lost repeatedly to a French jet that broke most of the rules its designers thought mattered. The lesson isn't that Western technology was inherently superior. American F-4 Phantoms struggled in some of the same scenarios where Mirages excelled. It's the Phantom's size, complexity, and smoke-trailing engines created vulnerabilities that skilled Soviet-trained pilots could exploit. The lesson is that specifications don't fight wars. Trained pilots operating reliable equipment within sound doctrinal frameworks do. System complexity is only valuable when it enhances rather than hinders operational effectiveness. When complexity creates brittleness, it becomes a liability. Flexibility and adaptability often matter more than raw capability. The aircraft that works when things go wrong beats the aircraft that excels when things go right. The Soviets learned these lessons eventually. The MiG-29 and Su-27 proved they could build capable close-range fighters when forced to acknowledge that their previous approach had failed. But by then, the strategic competition had moved to new domains. Precision-guided munitions, stealth technology, electronic warfare. The battlefield evolved past where 1960s era dogfighting doctrine remained central. And the economic cost of catching up had contributed to strains that would soon overwhelm the entire Soviet system. The arms race didn't cause the Soviet collapse, but it accelerated a decline that might otherwise have unfolded more slowly. A desperate design from a bankrupt nation. It's written off by every expert who evaluated it. It's flown by pilots who learned to make its weaknesses irrelevant and its strengths decisive. The Mirage 3 shouldn't have worked. The engineers knew it. The analysts knew it. Everyone who studied the specifications reached the same conclusion. That it worked anyway tells us more about the nature of military power than 1,000 specification sheets ever could. Effectiveness comes from alignment, not advantage. Systems that match their operating environment beat systems that excel in theory but break in practice. Human factors dominate technical factors. The best pilots flying adequate aircraft defeat adequate pilots flying the best aircraft. Simplicity provides resilience. When things go wrong, and they always go wrong, the simpler system keeps working, while the complex system cascades into failure. Somewhere in archives that were once classified, Soviet analysts spent decades trying to understand why their perfect system kept losing to a plane that wasn't supposed to fly. They generated reports, they proposed improvements, they developed new aircraft and revised doctrine. They never quite accepted the answer that the evidence offered. The problem wasn't their aircraft. The problem wasn't even their pilots. The problem was that they built for the war they imagined, while their adversaries prepared for the war they knew would actually come. That's the lesson of the Mirage 3, and it's a lesson that remains as relevant today as it was over the burning sands of Sinai in 1967. Next time on Shadowworks. The aircraft that flew higher than any missile could reach, and the Soviet pilot who almost stopped it. Subscribe now for the SR-71 Blackbird story you've never heard.